It's easy to look at a mountain stream and just see something picturesque. But what we're actually dealing with here is raw, unyielding kinetic energy. Every single drop of this turbulent water is being strictly directed by massive, ancient geological forces that are literally carving the earth as we speak. It kind of makes you wonder, who, or rather what, is actually drawing the map for a river?
Welcome to this explainer. Okay, let's dive straight into this, because today we're tackling a genuinely grand geographical puzzle. Think about it. Why do the massive rivers that originate way up in the Himalayas and northern India, and the ones starting down south in the Western Ghats, why do almost all of them flow east to dump into the Bay of Bengal? Seriously, what invisible hand is tilting the entire subcontinent?
To really understand India's drainage system, we're going to unpack what is essentially a tale of two completely different geological characters. We've got the wild, youthful rivers up north and the ancient, deeply entrenched rivers of the south. And to understand how they coexist, we have to look at the master plan hidden right beneath our feet.
Here's our roadmap for today. First, anatomy of a river. Then, India's drainage master plan, followed by the Himalayan giants. And finally, the ancient peninsula rivers.
Section 1. Anatomy of a river.
Let's start with a river's lifeline, its catchment area. A river doesn't just spontaneously generate water, right? The catchment area acts as a strict geographical boundary. Every single drop of rain that falls within that perimeter is mathematically committed to reaching that specific river. Now, when you scale that concept all the way up, you get a drainage basin. This is the entire massive area drained by a main river and every single one of its tributaries. And what's really fascinating here is the absolute unity of these basins. If you pollute the water or build a dam in one tiny corner of the basin, it directly impacts the entire system downstream. That's exactly why planners use these basins as their ultimate macro planning regions. You literally cannot manage a river without managing its whole basin.
And the thing separating these giant basins from one another? That's the watershed. It's the literal boundary line, usually a high ridge or a crust of land. It's incredible to think about, but if a raindrop falls just a millimeter to the left of a watershed, it journeys to one ocean. A millimeter to the right, its destiny is an entirely different sea. And depending on the underlying rocks, these drainage patterns form really distinct visual signatures over time. You get the spreading, tree-like branches of the dendritic pattern, or the outward burst of the radial pattern, flowing away from a central hill. Then there's the trellis pattern with its strict right-angle joins, and the centripetal pattern, where everything flows inward to discharge into a central depression.
Section 2. India's drainage master plan. There is an absolutely crucial central water divide running right down the Indian subcontinent. It's formed by the Delhi Ridge up north, continues through the Aravallis, and runs all the way down along the Sahyadris or Western Ghats. This single, continuous crest is the grand separator for the country's entire water flow. Because the Indian Peninsula is subtly tilted from the northwest down toward the southeast, we end up with this wild disparity in the data. A staggering 77% of India's drainage area, we're talking titans like the Ganga, the Brahmaputra, the Mahanadi, and the Krishna, flows east straight into the Bay of Bengal. Only 23%, which includes rivers like the Indus, Narmada, and Tapi, make their way west into the Arabian Sea. That is millions of years of continental tilting, summed up in one stark data point.
Section 3. The Himalayan giants. The rivers born up in the Himalayas? They are basically the unruly teenagers of the geological world. They are youthful, highly turbulent, and just incredibly active. Because the Himalayas themselves are still actively rising, these rivers are constantly carving deep gorges and sharp V-shaped valleys. And when they finally hit the flat plains, they drop insane amounts of sediment. Take the river Kosi, for instance. It brings down so much rubble from the mountains that it actually blocks its own channel, forcing the river to violently and suddenly change course. It happens so often and causes so much devastation that the Kosi is notoriously known as the Sorrow of Bihar. This whole northern drainage system is dominated by three massive basins: the Indus, the Ganga, and the Brahmaputra. And unlike a lot of rivers globally, these giants are perennial. They literally never run dry. Why? Well, they're running on a double engine. They get hit with heavy monsoon precipitation, sure, but they also get a massive influx of melting snow from the high glaciers during the drier months.
Now, get this. Geologists believe that between 5 and 24 million years ago, these three giant river systems were actually just one unfathomably massive mega river called the Indo-Brahma, flowing all the way from Assam to Punjab.
But earth-shattering tectonic shifts, specifically the upheaval of the Delhi Ridge and the downthrusting of the Malda Gap, acted like massive geographical wedges. So the three giant rivers we see today, they're actually the dismembered remains of one ancient mega-river. Wild, right?
Section 4. The ancient peninsular rivers. So if the northern rivers are unruly teenagers, the southern rivers, the Mahanadi, Godavari, Krishna, and Kaveri, are the older, far more mature waterways. They flow through broad, shallow, settled valleys. Most of them flow east, perfectly obeying that continental tilt we talked about. Now, there are major exceptions, like the Narmada and the Tapi, which flow west. But actually, they don't flow west by choice. They're trapped in deep trough faults, essentially massive cracks in the Earth's crust that ripped open when the Himalayas were being pushed up.
So, here's the ultimate takeaway. You have the Himalayan rivers, youthful, wild, continuously fed by snow and rain, violently shifting their courses across the plains. And in stark contrast, you have the peninsular rivers, ancient, seasoned, relying entirely on seasonal rainfall and flowing dependably through deeply fixed courses. It's a literal tale of two completely different systems sharing the exact same subcontinent.
Which leads us to a highly debated, really fascinating modern question. If one side of our country faces devastating floods from shifting sediment-heavy northern rivers, and the other side deals with strict seasonal water deficits in fixed ancient basins, can human engineering actually fix it? Can large-scale interbasin linkages, literally piping surplus water across these million-year-old watersheds, solve our modern problems? Or does playing plumber with the continent risk upsetting a very fragile geological master plan? It's a massive question for the next generation of engineers. Thanks for joining me on this explainer, and keep questioning the ground beneath your feet.